Hello guys, welcome back to the fourth lecture of this series, which is data preparation phase to model the data. Here we are going to learn five topics, which are how to partition the data in Python, how to balance the training data set in Python, and how to build card decision trees using Python, and how to build C5.0 decision trees, and how to build a random forest in Python. So, first is how to partition the data. Partitioning the data involves splitting your data set into subsets: training, validation, and test sets. What are training sets? Training sets are used to train your machine learning model. This is the largest portion of the data. Validation set used during training to tune hyperparameters and evaluate the model's performance without influencing the test results. Test set used after training to evaluate the model's final performance on unseen data, ensuring it generalizes well. In Python, the train test split function from the sklearn library allows you to divide your data into these subsets in a controlled and randomized way. Now, here is the code for partitioning the data. So, first we are importing sklearn and pandas. Then we are reading the your dataset CSV file where we are inputting in X and output will be given in Y. Now splitting the data into train, validation and test set. So 80% of the data will go to train set and 20% of the data will go to test set. Here you can see that we have given the size test size is equal to zero point 0.2, which represents 20% of the data, and now further splitting the temp set into validation and test set. So 50% of the 20. Now printing the training set and validation set and test set. This is the syntax of it. Now, next is how to balance the training data set. When your data set has an imbalanced class distribution, example many samples of one class and very few of another, your model may become biased toward of the majority class. To prevent this oversampling, duplicate samples from the minority class to balance the data set. Undersampling is remove samples from the majority class. S mode is synthetic minority oversampling technique, which generates synthetic examples for the minority class instead of duplicating existing ones. Balancing ensures that the model doesn't favor one class over others and leading to improved performance, particularly for the minority class. Now, the third topic is how to build card decision trees. CART is classification and trees. It is a decision tree algorithm that splits data based on the Gini index or mean squared error. It handles both classification, categorical target variable, and regression, continuous target variable. Steps to build CART in Python. First, there are three steps. Load and prepare your data. Use the decision tree classifier for classification. A decision tree regressor for regression from the sklearn library. Train the model and evaluates its performance. Card trees are interpretable and useful for understanding the decision making process of your model. Now, the last is how to build random forests. Random forests are an assemble learning technique that builds multiple decision trees and combines their predictions for improved accuracy and robustness. Each tree is built on a random subset of data and features, reducing overfitting. The algorithm uses majority voting for classification or average prediction for regression. These are three steps for building random forests. First is prepare and partition the data. As we have seen just now how to partition the data. Then is use random forest classifier. This is a function. It's given. It is inbuilt or random forest regression in Python. It is also an inbuilt function. Now third is train the model on the training set and evaluate it on the test set. We have just now seen how to create training set and test set. So random forests excel at handling large data sets, non-linear relationships and imbalanced data. This is the code for building random forest in Python. Here you can see that we have first we imported random forest classifier from sklearner. This is a library. It contains many functions. Now instantiating the random forest model. So first we have taken a variable rf model is equal to random forest classifier, and estimator is equal to 100 and random state is equal to 42. Now training the model. So rf underscore model dot fin x train balance y train balance. We are training the model by x train and y train. Now evaluate on the test set. We have we have y pred rf is equal to rf underscore model dot predict x test. We are evaluating x test. Now print accuracy score y test y prediction rf, and printing classification report, that is this syntax. So we have covered all the topics of data preparation phase to model the data. Thank you.